Hello friends, how are you? I hope all of you are doing well and strong enough. So today what we're going to do is we're going to start off with the concept of derivatives, class 11 chapter 13. Limits we have already done, so we're going to today learn about. So we are going to make it, I'm going to make it very short. We'll not go much into the details because that we may not need now. We just need to understand what is the concept behind derivative. What is derivative? When do we use it? How do we use it? What are its uses also? So I will try to make it very short for all of you. But the concept should be very clear because it's for competitive examinations. Concept is more important than just notes and memory, isn't it? So let's begin then. What are derivatives? So we will be, talking about we will be trying to understand this concept of derivatives in maybe 2 to 3 different ways. First one, what it says is, what is derivatives? What are derivatives, or what is it? It is nothing but simply the rate of change of one quantity with respect to another quantity. Rate of change of one quantity with respect to another quantity. What does it really mean? So it simply means like, how does one quantity, if they are dependent on each other, if one quantity is dependent on another quantity, so if one quantity is changing, how does the other quantity change? How does it change? Okay, what is the rate of change? Right. Now, of course, I've written here food, which everybody knows. I just wrote this to get your attention, just to get some of you might be feeling bored and all, so just to get your attention, because food, it's really eye-catching for all of us. But like, why do we have food? We have food actually to gain energy, isn't it? The more food we have, the more energy we have, the more healthier we become, right? So somewhat related to that, not exactly this, as I told you, just to get your attention, but it does serve its purpose. Why do we have food? To gain energy. How is it related? Does it relate to us? Definitely, the more food we have, the better food we have, the more energy we gain, isn't it? But alright, so yeah, something related to that. So we're going to talk about how does one quantity affect the other quantity. So now, for example, like rate of change of one quantity with respect to another quantity. Now suppose if I give you a function y equal to x squared. Now you see, look at this change, y equal to x squared. So what happens is, see, if x is equal to 1, how does y change? Y becomes 1 squared, that's alright, 1. If x is equal to 2, then what happens to y? 2 squared, then it becomes 4. If x equal to 3, then what happens to y? Y is equal to 3 squared, and it's like 9. So now if you look at this function, what we see is that y is completely dependent on x. So as x changes, y is also changing. Now our the purpose of derivative is to give us the rate of change of y with respect to x. So the question is, how does it change? What is the change and how do we know? Right. So here what happens is, as x is changing, y is becoming the double of x. So this was a very simple function, but not all the functions are so simple that we can simply say that, okay, as x changes, y becomes double and all, isn't it? So that is the purpose of derivatives, no? What is the rate of change of one quantity with respect to another quantity? What is the change? How does it change? How do we find out? Using derivatives, exactly. Now, we up to class 9 and 10 we have already seen speed. What is speed? Speed is simply the way we used to write. Okay, let me get another chalk. Speed, yeah. Speed, the way we used to write is what? Distance by time. So that was a more general way of explaining speed. But now, since you must have already done physics, speed now more specifically, it's like speed would be rate of change of distance, rate of change of distance upon rate of change in time. That would be more appropriate, isn't it, to define speed, now that we are in class 11 higher secondary classes. Now the question is, for example, like suppose I'm moving from one point to another point B. Now, maybe after 5 minutes, I've moved 10 kilometers. After 15 minutes, I have moved, let's say, 40 kilometers. Okay? Right. So now the question is, the concept is like we can clearly see that distance is completely dependent on time. Distance is completely dependent on time, isn't it? Distance is completely dependent on time, because as time increases, distance is also increasing, isn't it? But the question can be like, with respect to time, how does distance change? Now if somebody just asks you, with respect to time, how does distance change? And now this answer will be provided to you by derivatives. So I'm not going to discuss how exactly here, okay? As I just told you, we're just going to discuss on what is the purpose of derivatives, what does it give us, how does it help us. So derivatives actually tells us the rate of change of one quantity with respect to another quantity, how does it change. So with respect to time, how does distance change? That will be explained to us by derivatives. Now in class 11 and in 12 also we are going to see many applications of derivatives, about maxima, minima, error approximation, about this rate of change also. So there of course we will study more in details. Alright, but one thing is, see, but of course the main purpose of derivatives is it gives us, when we talk of rate of change, let's say for example speed, it actually gives us instantaneous speed, and that's one great advantage of derivatives. Like for example, to move from A to B, let's say in 5 hours, I took maybe a time of, let's say 7 hours, and my speed was, let's say 40 kilometers per hour. Alright, so my speed was 40 kilometers, average speed, okay, average speed was 40 kilometers per hour. But does it mean that throughout the whole journey I have been traveling at 40 kilometers per hour only? I don't think so, isn't it? When we calculate the average speed, it's just taken into the account of all the speed and then average with respect to time, right? So it doesn't really mean that maybe if I ask you now since it took 7 hours, maybe at 3 hours, what was my speed? So is it really necessary going to be 40 kilometers? Who knows? Because when we travel, what happens? Sometimes we stop, sometimes we increase the speed, so it doesn't really necessarily mean that throughout the whole journey I was, until unless it's uniform, throughout the whole journey I was traveling at a speed of 40 kilometers per hour. If you have observed in vehicles, what happens is there is a speedometer, isn't it? Speedometer. Now with the help of that speedometer, what happens is we can find out the instantaneous speed. So with the help of that speedometer, I can exactly tell at the third hour of my journey what was my speed, exact speed. So maybe your speed was, let's say 50 kilometers per hour. So that was the instantaneous speed, that was the speed at that instant, speed at exactly 3 hours, it was 50 kilometers per hour. So that's what actually derivatives gives us, that instantaneous rate of change, that is instantaneous speed. Okay, it's instantaneous speed. So that's one advantage. That's what that is how derivatives helps us. That's what it does. How does it change? If one quantity changes with respect to another quantity, okay, fine, we understand that rate of change of one quantity with respect to another quantity, fine, simple, understood. How does it change? How is one quantity changing when the other quantity is changing? So that relation actually is given by derivatives. Alright, another way to understand this is the graphical way, that is slope. But before that, we really have to understand two words. I believe you already know these two words, slopes and tangents. Now slopes, again, we will study in details in coordinate geometry when we do the other chapters of coordinate geometry. But let us just understand what is slope. So now, see, slope is nothing, okay, just the inclination, the angle of inclination, the tangent of the angle of inclination. Now, for example, you must have seen, if you have maybe, let's say, a wall and then a step. A ladder is kept on the wall. So now what happens is this ladder makes an angle, definitely with respect to the floor. Now the tangent, so generally denoted by m, slope, the tangent of the angle of inclination is called the slope. Alright, so at what angle, it's simple, okay, very simple concept with slope. At what angle, what is the inclination, at what angle, and the tangent of that angle, it's actually about angle of inclination, and the tangent of the angle of inclination is called as slope. So some slope may be this. So definitely if you have a graph, then of course the exact graphical way of understanding slope is if you have x-axis, you have y-axis, then maybe there is a line. So the angle which the line makes with respect to the x-axis, positive direction of the x-axis, angle always remember measured anti-clockwise, positive, the angle which a line makes with the positive direction of the x-axis, not in this direction, in that direction, the angle, this angle is called actually angle of inclination. Alright, angle of inclination, and the tangent of this angle of inclination is simply called as slope. So it basically tells us, gives us, so for example, if I say that the angle of inclination is, let's say, like 45 degree, then what will be its slope? Tan 45 is 1. Right? Simple as that. Alright? So suppose if I have another line, maybe angle of inclination is more. So whose slope will be more? Definitely see if you can connect that to our common sense. Definitely which you can simply see, isn't it? Which line has more slope? Definitely this line has more slope because the angle of inclination is more. So slope is nothing. How is a line inclined with respect to the x-axis? So the bigger, the more the slope. Alright? Of course it can go to negative also, but more about that we will discuss in the later classes. Now we can also find out how to find out the slope of a line which is passing through 2 points. Now these are ways. If you have the angle of inclination, then that's good. That is, slope will be simply tangent of the angle of inclination. But suppose if this is not given, alright, if this is not given, but whereas 2 points are given, maybe that line is actually passing through 2 points, x1, y1 and x2, y2. So in that case, how do you find out the slope? It's simple. The slope that we find out will be simply y2 minus y1 divided by x2 minus x1. So this is the way we find out slope. So let's remember this. Let's keep that in mind, because maybe after a few minutes we are going to need the concept of this. So here, simply how to find out the slope of a line passing through 2 points. This is the way we find out. Alright, as I've mentioned, more about slope we will study when we really study coordinate geometry in detail. Alright, now just what is slope and how do we calculate slope. Alright, so slope concept, very simple. How is a line inclined? Slope gives us that. Alright, next, tangent. Now tangent, all of us we know. What are tangents? Tangent is nothing but a straight line that passes through only one point on the given curve. Of course, up to class 10 we discussed only about circles, but circle is also a curve. Alright, so it's a straight line passing through a curve, touching at only one point. So maybe this is one curve, so this can be a slope, no problem with that. I mean tangent, sorry. So that can be a tangent. So a tangent is a line which passes through one point. So actually we can have many tangents. Maybe, I don't know, okay, maybe here, maybe we can have a tangent, maybe, of course, slightly, if we can see this is one tangent, right? So we can have many tangents. On a circle also we can have many tangents. So a tangent, I hope you understand, it's simply a straight line which passes through just one point. So these two concepts we are going to be requiring, because what do you mean by derivatives? Derivatives is simply nothing but derivative simply gives us the slope of a tangent. Okay, what is derivative? Derivative is nothing but the slope of a tangent. Derivative is nothing but it gives us the slope of a tangent to a curve at a given point. Now, for example, suppose this is a curve. Alright, suppose if this is a curve, then maybe at this point, what will be, can I draw a tangent? First thing is that, can I draw a tangent? Definitely yes. I can draw a tangent here passing through one point. Alright, now derivative, what it does is, it gives us the slope of this given tangent. Alright, so if we have the angle of inclination, we can find out. No problem with that. Alright, so derivative is nothing but the slope of a given tangent to a given curve. So that is what derivative gives us. Is that clear? Okay, but there was one problem later on with mathematicians, that is, suppose you have a curve maybe like this. Suppose you have a curve like this. Alright, and there are 2 points. Let's say 1 point here and 1 point there. Now, if my question is find out the derivative, or find out the when I say the question, find out the derivative at these 2 points. So that means for that, of course, first I have to get a tangent that passes through these 2 points. That's what I have to do first, because slope derivative is nothing but what? Slope of a tangent. Now, to get the slope of a tangent, what do I need? I need the tangent first. So if there are 2 given points, then I have to first draw the tangent passing through both the points, passing through the 2 points. Now we know that literally it's not possible, because you see that the moment I joined these 2 points, what happens? It is no longer a tangent. Actually, what does it become? It becomes a secant. It does become a secant. Secant we used to call it. So it's no more a tangent. So now how do we get a tangent? So this baffled most of the mathematicians. How do we solve? So now my problem is, how do I get the tangent? So what they did was, they thought about it, and then maybe they just thought that, for example, this was the point. So what can be done maybe is, what if, suppose this was the point, alright, A. So maybe the first point was B, so it was not possible to draw a tangent. What if I bring the point closer? Will I be able to draw a tangent? Not yet. What if I bring it more closer? Will I be able to draw a tangent? Almost, but not yet. So if we keep on doing this, what happens? If we bring the point very, very close to A, then I think we can draw a tangent that is passing through both the points. Of course, curves can be all different, okay? So if I bring the points very, very close to each other, very, very, very close to each other, then definitely I will be able to draw a tangent. And once I'm able to draw a tangent, I can always find out the slope of the given point. How do we find out the slope of a given point? That will be, what will be my point A here? x1, y1. What will be my point B here? Of course, I will just try to manage here, x2, and then very, very close, okay? Very, very, very close. That's going to be y2. Alright, very, very, very close. So what will be my slope? That's going to be y2 minus y1 divided by x2 minus x1. And that is how we will be finding the slope. But if you see, as I mentioned again, when is it possible? It is possible, especially passing through 2 points, it is possible only when these 2 points are like what? Very, very, very close to each other. Because if the points are too far, what happens? We don't get a tangent, we get a secant. And derivative is not slope of a secant, derivative is slope of a tangent only. So to get the tangent, what we have to do is that we have to bring the point very, very, very close to each other. So that means this interval that we call it, no? This interval is like approximately equal to like 0, maybe 0.0001, very, very close to each other. So automatically what happens is, even this interval is like what? Very, very, very small. Alright, so now as per definition, I hope all of you remember the concept of limits. As per definition, what happens is, the limiting value of the change in interval y to the change in x. Okay, let me just write like this. That is, limiting value of y2 minus y1 upon x2 minus x1, as x2 minus x1 is very, very close to each other, is almost 0, is actually given as, or is actually known as, the derivative of y with respect to x, rate of change of y with respect to x. This of course can also be written as limiting value of the change in interval, okay, the small interval. Alright, the small interval, very, very small, okay, this is going to be like very, 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 very small. Okay, increment we used to call it, increment. Upon increment in x, as the change in interval, as the distance between the 2 points is very close to each other, that is approximately 0, is known as the derivative of the function with respect to x. Okay, let me round it out very quickly. That is, when is a tangent possible for you? When is it possible for you to draw a tangent passing through 2 points on a curve? Only when the tangent is only when the 2 points are very close to each other. That means only when this distance, this interval, this increment is very small. Only when this increment is very small, then I will be able to get the slope of the given tangent. And that is exactly what is derivative. Because once I am able to get the tangent, I will be able to find out the slope of the tangent. When am I able to find the slope of the tangent passing through 2 points? Only when the interval is very small. And that is known as derivative of a function with respect to another function. So that's the simple concept of derivative. I hope that's clear. Okay, so I repeat once again, derivative simply is nothing but derivative is simply what? Slope of a given tangent. So now if a function is given to us mathematically, y, alright, if a function y is given to us, then the limiting value of the increment in y upon increment in x, as the increment in x tends to 0, alright, is called the derivative of y with respect to x. Or in other words, it is also like, for example, if this is my function, we just assume this to be the graph, and then maybe this is the curve, maybe. So only when maybe at this point x, this is my function f of x. Now for a very small increment, let's say maybe this increment is, let's say, h, okay, very small, then this, let's say this point be x plus h, then the value of this function will be what? F of x plus h. So this can also be denoted as limiting value of f of x plus h minus f of x upon h, as the interval is very small, is also the derivative. So again I repeat, graphically, what is the geometrical interpretation? That is, what is the meaning of derivative? It is simply nothing but slope of a tangent. Problem comes when you have to find out the slope of a tangent passing through 2 points. When is that possible? Only when the 2 points are very close to each other. So that's what generally derivative is just trying to give us. Alright, but it is a very useful process. Okay. Now, there are some ways to denote derivatives. That is, of course, as I've written here, it's given to you. Alright. So if a function y f of x is given, then derivative of the function y with respect to x can also be denoted by f dash of x. Alright, f dash of x. So that is known as derivative. And the process of finding out the derivative, what is the derivative? Slope of a tangent. The process of finding out the slope of a tangent, please note it down, okay? The process of finding out the slope of a tangent, or in other words, the process of finding out the derivative is known as differentiation. Is simply known as differentiation. So differentiation is not a new word. I mean, it's not a separate word. Okay, differentiation is simply the process of finding out the slope of a tangent to a curve, or in other words, in very short words, the process of finding out the derivative of a function at a given point. Alright, is known as differentiation. Alright, I hope that is clear to all of you. So finally, let's round it up. What is derivative? When we talk of the physical aspect, interpretation is simply what? The rate of change of one quantity with respect to another quantity. So how does, provided they are dependent on each other, so how does y change? So for example, suppose if this is a graph, x-axis, y-axis, and this is a line. So definitely we can see that as x is increasing, y is also increasing. As x is increasing, y is also increasing. As x is increasing, y is also increasing. So it simply gives us a rate of change of one quantity with respect to another quantity. But the question is, how does it change? What is the process? What happens to y as we increase x? Is it doubling? Is it becoming smaller? Is it becoming bigger? That is what derivatives will explain to us. Alright. Another important aspect is derivatives helps us, very importantly, derivative helps us in finding out, like when we talk of speed, it gives us instantaneous speed. What is the speed of the car at that particular time, at that moment? For example, speedometer. Alright. Graphical meaning, it simply means to find out the slope of a given tangent. So you have to first draw a tangent and get its slope. Alright. So finding out the tangent. So when I write this, it's simply what? Graphically, what is the graphical interpretation? It simply means what? To finding out, this is simply what? The slope of a tangent to a given curve. Is that clear? This is simply meaning slope of tangent to a given curve. Alright. So graphical meaning interpretation would be to find out the slope of a given tangent. So that is what is derivative. Of course, the topic is very vast. Okay, we can just go on talking and talking and talking, and explanation, it will just go on, because every teacher, every person has his own way of understanding derivatives. Even you, after listening to this, you will find your own ways, and these are all very good. Okay, knowledge, this is not like limited within the books. We have our own ways of understanding. Okay, we have our own ways of understanding and applying it. So you watch different videos, all the videos will be, most of the videos will be like different, but they will just revolve around the same concept only, same concept. So it's that concept that you're supposed to understand. All right. Okay, now leaving that aside, let's see. Of course, there is another way of finding out. I mean, there are different ways of finding out derivatives, but we are going to do the direct method first. Let's first learn the direct method of how to find out the differentiation. All right, how to do differentiation, and then maybe we will do the other method in the other videos, using the first principle method and the other methods. All right. So a small hint I've already given here on how to find out the first principle, but we will discuss about that later. Let's go to the direct method first. So to use the direct method of differentiation, let's get some formulas. Alright, please write down. The first rule will be this: derivative of x power n with respect to x. Always write down the function outside, that's better, because this is derivative with respect to x. The function, which is the function here? X power n. It will be n into x power n minus 1. Alright, n into x power n minus 1. Then of course, derivative of the exponent function e power x will remain same, it will not change. Then we have derivative of log of x. Derivative of log x will be 1 by x. Then this is one formula which we do not use very much in higher secondary, but doesn't mean that it does not exist. It always exists. Derivative of a power x. That's a power x into log of a. Then of course written. Shall I rub it off now? Okay. Then derivatives of some trigonometric functions also. These are all formulas which we are going to need. So that will be number 5. So derivative of sin x. Derivative of cos x, derivative of tan x. So derivative of sin x will be simply cos x, derivative of cos x will be minus of sin x. Okay, derivative of tan x will be sec square x, derivative of cosec x would be minus cosec x into cot x. Alright. Visible, derivative of sec x would be sec x into tan x. Derivative of sec x would be sec x into tan x. And one more, that is derivative of cot x will be minus cosec square x. So this would be some of the basic theorems or the basic rules or basic formulas to proceed with differentiation. Okay, some results. Alright? Okay. Is that clear? Fine. Now, some small basic things which we will require, like what is the derivative of a constant with respect to a variable x? Now we write usually x here, but this variable can be different because See, I might want to find out what is the change in distance with respect to time. Fine. Another person might just want to find out what is the change in speed with respect to time. That's also fine. So another person might be interested in finding out what is the change in the y-axis, in the y dimension with respect to z-axis. So all these dimensions can be different, okay? So, but in general, of course, we write with respect to x. Alright, the graph may be like this. I'm asking you what happens to y with respect to x. But this can change. What happens to t with respect to d? What happens to z with respect to y? So see, this can change, okay? It's just a general formula we're supposed to keep in mind. Alright, not every time with respect to x. As I repeat again, change in one quantity with respect to another quantity. But what are the quantities? That can differ from person to person, conditions to conditions. Alright, now here, what I want to find out is what is the change in, derivative of a constant quantity with respect to x. Now for this, very simple, listen to me. If I ask, what is the change in the quantity 4, I'll write here, with respect to x. So what I'm trying to ask you here is, if I change x, okay, if I change x, what will happen to 4? As x changes, what is going to happen to 4? Think. As x changes, what is going to happen to 4? Will 4 change as I change x? Definitely not, isn't it? Because 4 remains 4 only. This is a constant quantity, there is no variable attached to it. 4 is not related to x. 4 is independent of x, not dependent of x. It's completely independent of x. So it will not change. So no change means what? It will not change. So it will not change means 0. That means 0 represents no change. Negative means it's going to decrease, right? This quantity will decrease. Positive means this quantity is increasing. Simply the simple meaning is that. How does it change? But mathematically, how do we solve? Like for example, what is the derivative of a constant quantity? Let's say a, where a is assumed to be any arbitrary constant. So now what happens is a is an arbitrary constant. So what will happen is, let's say, for that of course we have to learn some basic rules. That is first one. You can algebra of derivatives. So first one you write down. Derivative of addition of two functions, u plus v, can also be written as derivative of u plus or minus. I'm just writing plus or minus together. Okay, derivative of v by x. That means you can just separate them, no problem with that. Second would be derivative of maybe a constant quantity into, let's say, into a function of x. Constant quantity can be easily taken out, not a big issue with that. Alright, I'll write here. Third would be, how will you differentiate a product of two functions? That will be simply alternatively, very easy to remember, that is u into derivative of v with respect to x plus v into derivative of u with respect to x. Simple, turn by turn, alternatively you will differentiate this, and this is a very special rule. This rule is called as product rule. We're going to be doing more problems on product rule also. Another one will be, what about quotient functions? Like if one function is divided by another function, in that case what will happen is square of the denominator, only the square, denominator into derivative of the numerator with respect to x minus numerator into derivative of the denominator with respect to x, and this is called as quotient rule. Alright, this will be called as quotient rule. So please take a note of this formula. It's going to be very, very useful now forever. Now going back to that, what is the derivative of a constant? Now let's see, what is the derivative of a constant? That is, let's say, derivative of 4. So what I can do is 4 I can take out, that will be derivative of now 1. So now 1 I can write x power 0. No problem with that, isn't it? Because anything to the power 0 is 1, so 1 I can replace it with x. So here what I will do is, I will try to use the formula which I gave you, that is x power n formula. So what was the formula? N into x power n minus 1. So if I try to use that, n into x power n minus 1. So 0 into anything is what? 0. So exactly as I told you, as we discussed, 4 is not going to change with respect to x. So these are some basic things. Another basic thing would be, which we will require every now and then, which we will not do repeatedly again and again, that is derivative of the function with respect to itself. So how will x change as x is changing? So it will remain same. If x is 1, the other x is also 1, no, if they are directly related to each other. So in that case, what will happen? It's x power 1. So 1 into x power 1 minus 1, using the formula 1 into x power 0. Anything to the power 0? 1. Alright, that means it will remain same. I mean same rate of change. Got that? Same rate of change. Alright? Okay. So fine then. So let's quickly try to solve one or two questions and then we will wind up for today. That is, let's say first question, example, that is if a function y is given, let's say x square plus 4y x cube minus 2 by 3 tan x plus 6, let's say. So my question is, how do we differentiate this? So let's begin. Derivative of y with respect to x. Let's write slowly. Derivative of this function with respect to entire function with respect to x. So this side, let it be. So in the algebra of derivatives, with addition, subtraction, we can just keep them separate. No, we can distribute them. So I'll write one more step, that is derivative of x square plus first time, so we will do it slowly. Derivative of 4 by x cube, we will write many steps. Derivative of 2 by 3 tan x plus derivative of 6. Now we will do some arrangement, proper arrangement. We will not differentiate, we will differentiate together in the last. Plus, see, 4 is a constant. So one hint that I'm giving you is every time you see an independent constant, take it out. In the algebra of derivatives, I've already given to you. So constant, you just take out. No need to keep that constant. Okay, and I hope all of you can recognize constants. Here also 2 by 3 I'll take out. And here, of course, I will not calculate because 6 is a constant. 6 is a constant, so derivative of a constant is always 0. No need to think also. Blind shot, just 0. Now, still a little bit more arrangement before I really start applying together. Of course, most of the steps you can reduce later. Plus 4 by c, derivative of 1 by x power n. Of course, you can use quotient rule, but who's going to use quotient rule for such simple questions? What I'll do is, I'll try to use x power n formula, so I will add x power minus 3, then only I can use, no? 2 by 3 derivative of tan x, 0 I am not writing. Alright, so now that x power n formula we can use. So what was the derivative of x power n formula? Derivative of x power n, I'll write here. Derivative of x power n formula was power n. N into x power n minus 1, so it's 2 here. 2 into x power 2 minus 1 plus 4 into here n into x power n minus 1 minus 2 by 3. What was derivative of tan x? It was sec square x. So that's going to be 2x minus 4 3s are 12, x power minus 4 minus 2 by 3 sec square x. So this is derivative of your given function. Got it? Okay. Can I wrap it up? Alright. One last problem. Okay. And then in the next video we will try to solve some exercise. Okay. Let me just choose. Alright. This is interest. This is fine. X plus 1 by root of x whole square. So how do we differentiate this? Let's differentiate whole square. So now before I really differentiate this, see, x power n. We can using chain rule, but we haven't studied chain rule as of yet, so we will just simplify first before we differentiate. Okay, so I'll use a plus b whole square formula. So class 11, I believe all of you know, a square into twice into a into b plus b square. So that's going to be x plus 2 plus 1 by x. Maybe I'll just arrange a little bit more because I know what is going to be my differentiation. So x, I'll write x power minus 1. Last question we did that. Okay, so now what you can do is you can write down, please write down differentiating, please write down differentiating both sides with respect to x, differentiating both sides with respect to x. So that's going to be dy by dx equal to, I'll write now directly, that is, I'm going to start splitting them. No need to write so many steps again and again, isn't it? First problem I've already explained that this is what we can do. So derivative of x with respect to x, what did we study? Okay, I'll just write here 1, no problem, one more time I'll do. Next time I'm not doing, okay. 0, 2, 2, 2, 0 plus minus 1, x power minus 1 minus 1. So that's 1 into x power 0 plus 0, no need to write. So minus 1 x power minus 2 into, so x power 0, anything over 0, 1 minus x power minus 2. You can leave it there also, you can just write 1 by x square also. Okay, so this is what differentiation is all about. It's a huge topic, but I tried my best, just to, make it very compressed. I tried to compress it, so just to understand the concept only. Okay, but if we keep on explaining, then as I mentioned, it's a very huge topic. So I tried my best. I hope I could be of some help to you to give you a small concept about differentiation, but as I also understand that is not enough, but as I have been repeatedly telling you, I tried my level best just to compress it as much as possible, but that's not the end of it. It's huge. Okay, but of course you'll have plenty of time. You study in class 12 also. So alright then, so if you've liked this video, please don't forget to subscribe, share, get me more subscribers so that I can reach more subscribers, so that I can go live also, live classes where I will be sharing shortcuts and tricks that I know with all of you. Okay, so of course I need your support for that. So alright then, till then, take care. See you in the next video with more problems on differentiation, derivatives.